So let's consider now a second example. We're going to ask a slightly different question. What is the probability of observing one H, or one spike? Now remember, we saw that in 4 coin flips, there are 4 possible ways to observe H once. And we listed all of these scenarios on one of the previous slides. And this H may occur in the first position, the second position, the third position, or fourth position. We don't care where it occurs, specifically in this instance. All we care about is one H occurring in our 4 flips. And we've listed all possible scenarios where that can occur in these 4 coin flips. And let's consider the first pattern. And we can ask, what is the probability of this first pattern that we've highlighted in the red box? So let's break this up into individual components, and we can ask, what is the probability of observing H on the first flip? So the probability of H on the first flip, it's our biased coin, and the probability of heads is low, 0.1. Let's consider now the second flip. What is the probability of observing T on the second flip? Well, we know the probability of T in our biased coin is equal to 0.9. So we just write that value down for now. What about the probability of T on the third flip? Well, remember, it doesn't matter what flip we look at. The probability of observing tails is always 0.9, and the same is true of the fourth flip. We flip our biased coin, the probability of tails is still 0.9. So the probability of this first pattern, the way we compute it is we multiply together the probability of heads in the first flip times the probability of tails in the second flip times the probability of tails in the third flip times the probability of tails in the fourth flip. So we're going to multiply all of these values together. We've written that out explicitly here. The probability of heads in the first flip, tails in the second flip, tails in the third flip, tails in the fourth flip. So we take these 4 values and we multiply them together. 0.1, we have a low probability of heads on the first flip, times 0.9, a high probability of tails in the second flip, that same probability of tails in the third flip, and the same probability of tails on the fourth flip. And if you compute those values, we get this number, 0.0729. So we now have a probability of observing this sequence, heads, tails, tails, tails. We observed 1 H on the first flip. So what about this second pattern? So we said we have 4 patterns. We have 4 possible ways of observing 1 H in 4 flips. We've thought about the first pattern. Let's consider this second pattern where the spike, or the H, occurs on the second flip. So what is the probability now, focusing on this second pattern shown here in the red box? Well, again, we can break it down into individual components. We can look at the probability of T on the first coin flip. So the probability of tails, it's our biased coin, and it's always equal to 0.9. What about the probability of H on the second flip? So the probability of observing a spike, observing H, said it's always the same, 0.1 for our biased coin. What about the probability of tails on the third coin flip? Again, it's 0.9. The probability of tails on the fourth coin flip, again, is 0.9. So if we now want to compute the probability of this second pattern, on the previous slide we looked at the first pattern, now we're focused on the second pattern, what we'll do is multiply these probabilities together. So we'll multiply the probability of tails on the first flip times the probability of heads on the second flip times the probability of tails on the third and fourth flips. And we multiply those 4 values together, and we get the same number as before, 0.0729. And notice all we've done is move the probability of H from the first position, right, this 0.1 from the first position in our previous flip, to the second position in our second pattern. So we get the same number. We've just moved around these values and we're performing multiplication. So we get the exact same value, the exact same probability of this pattern, the second pattern, as we got for the first pattern. And we can also consider the third and fourth patterns. What are the probabilities of these patterns? Well, if we think about the third pattern, we want to know the probability of tails on the first flip times the probability of tails on the second flip times the probability of heads on the third flip in our third pattern times the probability of tails in the fourth flip. We get the same value as before. We're just multiplying the same numbers together. All we've done is move them around in this multiplication. And the same for the fourth flip, where in this case the probability of heads is the last flip, but we're going to get the same probability for this fourth sequence as we got for all of the other sequences. So what is the probability of observing 1 H in 4 coin flips? Probability of observing 1 H, 1 spike, in 4 coin flips. We've seen that there are 4 ways to do it. All right, so we're going to add up those 4 different ways. We have the probability of a spike on the first coin flip, where notice the H is in the first position. And we're going to add to that the probability of a spike on a second coin flip. Second position, the same for the third flip, the fourth flip. So we have the probability of H on any of the first, second, third, or fourth coin flips. So these are 4 different ways we can observe one H in 4 flips. And we're going to add up all of their probabilities. And we computed explicitly the probability of each of these possible outcomes. And we saw it was 0.0729 in each case. And if we add up all those values, we get the following, 0.2916. So what's the conclusion here? If we flip our biased coin 4 times, we expect to observe H one time 29% of the time. So we flip our biased coin 4 times, we expect to observe one spike, one H, 29% of the time. An important note here is we don't care when this spike occurs. It could occur in the first coin flip, it can occur in the last coin flip, or the second or third. We don't care where it occurs. All that we care about is that we get one H, one spike in 4 flips. So in this way, we can work out the probability of observing each number of spikes in 4 flips. So if the number of spikes is 4, that means we're going to flip our coin 4 times, we're going to get an H each time. And we found that this probability was very small, 0.0001. Very unlikely because our coin is biased. And so it's very difficult for us to flip a coin 4 times and get H each time. Because our coin is biased, the probability of observing H on each flip is low. What about the probability of observing 3 spikes? And we saw that there are 4 different ways to observe 3 spikes. Notice we're moving the tails position around in these 3 sequences. And this has some probability. It's still low because it's hard to flip our coin and get an H. It's a biased coin. What about the probability of observing 2 spikes? Notice in this case there are 6 different patterns that have 2 spikes. This has some probability, also quite small, about 0.05 in this case, or 486. What about observing 1 spike? We worked this one out explicitly, and we saw that the probability of observing 1H, 0.2916. What about the probability of observing no spikes at all? That means we flip our coin 4 times and we observe T each time. We don't get any spikes in this case. This has a very high probability. So it's very likely we'll flip our coin 4 times and not observe a spike. And that's again because our coin is biased. When we flip our coin, there's a 90% chance we're going to get a T. So if we flip our coin 4 times, it's very likely we're going to see T each time. So one other thing to note, if we sum up all of these probabilities, so the probability of 4 spikes, 3 spikes, 2 spikes, 1 spike, 0 spikes, so if we sum up all of these numbers, their sum is 1. And that has to be the case because it's 100% certain that if we flip a coin 4 times, we're going to get one of these sequences. There are no other possible sequences we can get. So the sum of these probabilities must be 1. We've listed all possible outcomes here of 4 coin flips. Okay, now this example is very simple. We've only looked at 4 subintervals. In reality, for real data, we expect many, many more subintervals. So instead of 4, we might have 100 or 1,000 subintervals to investigate. How do we deal with this scenario of many subintervals? We'll get into that on Wednesday. And so what we'll do on Wednesday in this week, we'll consider more of these subintervals, thinking about the binomial distribution, and then actually writing down the Poisson distribution. So we've talked about our statistical model as coin flips, and we'll represent this Poisson distribution, see what it looks like on Wednesday.